Good day everyone, this is Engineer Royce Formaliza and welcome dito sa ating Logic Circuits and Switching Theory. Okay, so last week natapos na natin yung discussion natin about the combinational logic circuits. Okay, so ngayon naman we will discuss our new topic which we call the sequential logic circuits. So balikan lang natin, 'di ba? Sabi natin in digital logic circuits, we can classify digital systems into two types. We have what we call the combinational logic circuits and we have our sequential logic circuits. Now, sabi natin, a combinational logic circuit, this is made up of logic gates where the outputs is only determined by the present combination of the inputs. It does not consider yung previous inputs natin or yung previous outputs natin. On the other hand naman, our sequential logic circuit is a little bit more complicated. Why? Although this is also made up of logic gates, now sa sequential logic circuits we have what we call the memory cells. Ibig sabihin, yung output natin, yung nagde-determine ng output natin is not only the present input but it will also depend dun sa state ng ating memory cells. So yung palang previous state ng output natin, magkakaroon na siya ng effect dun sa ating present situation, dun sa present input and dun sa magiging present output. Okay, but although medyo complicated na siya in definition, this is actually the building block of our digital system, yung logic gates natin. That's why right now we have the benefit, no, yung ating mga solid state devices, yung ating mga ROMs, yung storage natin, flash drives natin. It's because we have this device that can hold a certain information. Diba? Kung hihimayin natin yan, mapupunta tayo dun sa basic memory cell which can hold, in terms of digital systems, which can hold 1 bit of data. So that is our sequential logic circuits. Now, nasabi natin ito that the outputs of this logic circuit at any instant of time will depend sa present input as well as dun sa past outputs. Okay, so dalawa na yung kino-consider natin. Yung input niya at present and yung past output. So bakit ginagamit yung past output? Kasi meron na tayo ditong tinatawag na feedback element. Yung previous output kasi, nafi-feedback natin yon pabalik sa input side. So it will have an effect sa overall behavior of our system. Now, this block diagram shows us paano nag-ooperate ang isang sequential logic circuit. So we have our input here, external inputs natin, and then papasok yan sa next state logic circuit natin, and we have our memory elements bago yan magkaroon ng output logic. Now, ito yung sinasabi nating feedback. Yung output ng memory element natin will be fed back to the input. Okay, tapos yung input na yun, magke-create yun ng bagong memory. And then, papasok ulit yun or if feedback ulit yun pabalik sa input. Now, this memory element is a medium which contains an information. Since this is digital circuits, that information may be a logic 0 or a logic 1. And since this is a memory element, this information can be stored or retained until necessary. Okay, so magdedepende na yan. Hanggang kailan ba yung necessary? So we have what we call our ROMs na they are non-volatile memory elements. Ibig sabihin, kahit mawalan na ng supply yung circuit ko, yung information na na-store natin sa memory element na yon ay nandun pa rin. Kung RAM naman siya, well, the information is there until i-refresh natin or until i-off natin yung device. Okay? So, there are also memory elements that may be replaced, yung information stored within them. There are memory elements that once you burn that information into that memory element, hindi mo na pwedeng baguhin ulit. So, may mga ganon, di ba? Meron tayong mga tinatawag na EEPROM, EEPROM, di ba? So, those are the types of these memory elements. But, that will not be the topic of our discussion. Sequential circuits are broadly classified into two main categories. So, we have sequential logic circuits that is clock. So, ang tawag natin dyan ay synchronous sequential logic circuits. And meron naman tayong sequential logic circuits that are unclocked. So, we call this asynchronous naman. So, what is the difference between the two? Yung isa clocked, yung isa unclocked. Well, the synchronous sequential logic circuit, yung behavior niya is being defined by a discrete instant of time. Okay? So, paano yon? Ibig sabihin, to attain synchronization between the logic levels, there is a timing device. We have a clock for that system. And yung pag-change nung state ng bawat logic gate or ng bawat stage in that circuit will be timed by clock. So either it will be triggered sa leading edge nung system clock or it will be triggered at the trailing edge of the system clock. Well, the point here in synchronous sequential logic circuit, any change that will happen in the circuit or in the system, sasabay siya sa clock. At sabay-sabay sila mag-change. Yun. Yung asynchronous naman, ano naman ito? Well, yung behavior ng system naman may change regardless kung nasa leading edge or nasa trailing edge ng clock. Or actually, it doesn't matter kung may clock man or wala. Asynchronous ito. Okay? Ibig sabihin, the output will be affected whenever the input changes. Hindi na siya mag-aantay nung clocking dito. So, the commonly used memory elements in these circuits are the time delay devices. So, ito yung pinaka-definition ng asynchronous sequential logic circuit natin. It doesn't need a clock pulse for it or for the output of this circuit to change. What it only needs is the input and of course yung past output niya. Pero yung synchronous sequential logic circuit, kahit anong palit natin sa input, alam mo, ito yung synchronous natin. Kahit anong palit natin dito sa inputs natin, hanggat hindi sumasabay yung clock, alam mo, 0 pa rin yung clock, wala tayong makikita sa output niyan. Okay, pero pagdating dito, alam mo, ito, nag-change ulit siya from 0 to 1. Kung sumabay yung clock, dun pa lang sasabay, magkakaroon ng change sa output. Okay? Pero kung yan ay asynchronous, every time nag-change yung input natin, it will correspond to a certain change sa output natin. Okay, that is asynchronous sequential logic circuit. Now, the basic sequential logic circuit that we have is our flip-flop. This is actually the basic memory element. Bakit? A flip-flop can store 1 bit of memory. So dahil digital logic circuits ito, and we are talking about binary system, so yung state ng memory, ng digital memory, will be either of the two. It can be on a high state, meaning logic 1, or a low state, meaning logic 0. So this is our flip-flop. As you can see here below, this is an example of a flip-flop. A flip-flop can be constructed, it can be obtained by using either of these two universal logic gate. So, alam naman natin sa previous discussion natin that a NAND gate and a NOR gate is considered as the universal gates. Okay, so we can use either of these two to create or to construct a flip-flop. And ito po yung itsura ng ating flip-flop. As you can see here, it uses two NAND gates with its input. Yung isa sa input niya is S, yung isa sa input niya is R, and then it has two outputs. One is Q and the other is the complement, so Q complement, and then yung output naka-feedback pabalik. So yung Q naka-feedback pabalik dun sa NAND sa baba. Yung Q complement naman naka-feedback pabalik dun sa NAND sa taas. So this is our flip-flop, and this is a sequential logic circuit. Pasok to dun sa definition natin, di ba? Because the output will now depend on the present input dito sa S tsaka R and the past output. Ito yun, sa inputs A and B. Okay? Flip-flops are also called bistable multivibrators, or minsan tawag sa kanya BMV. Bistable in a sense that meron siyang dalawang stable state. What does it mean? It means that it can have an output of 1, stable yon, and it can also have an output of 0. So that is our flip-flop. There are different types of flip-flops. Yung kanina, nakita natin, this is an SR flip-flop. This is the most basic flip-flop, and all other flip-flops are a modification or an improvement of the SR flip-flop. So, ang uunahin natin, pagka-aaralin natin ng flip-flops, of course, none other than our SR flip-flop. This is a 1-bit memory bistable device. Meron siyang 2 inputs. Alam na natin to kanina. One is S. It means set that is the set input, and the other is R, which is the reset input. It also has two outputs, output Q and the complement of output Q. So nasabi natin this can be implemented by NAND or NOR gate. Here sa left you will see the same type of flip-flop. Both of this is an SR flip-flop. Yung nandito sa taas, it uses a NAND gate, and yung nasa baba uses a NOR gate. Now mapapansin nyo, yung NAND gate uses an extra gate. Bakit? Kasi if we will not use these extra gates na to, ang magiging S and R input natin would be complement. S and R complement. Now, alam natin that etong configuration ng NAND gate with the inputs common, this acts like an inverter. So, effectively, we are putting an inverter dito. Ayan. Sa S and R. So, instead of writing S complement and R complement, we can now write S and R. Okay? Now, etong nasa baba, NOR gate ito. So, dahil NOR gate yan, we don't need to invert it anymore. Okay, so gumamit lang siya ng dalawang NOR gate lang. But regardless kung alin dyan yung gagamitin natin, you can see that their truth table are the same. So since we have two input variables, we have four possible combinations. That would be 0, 0, 0, 1, 1, 0, and 1, 1. Now, ang pinag-uusapan sa mga flip-flops, ano yung magiging output niya? Depending dun sa input combinations. Okay, so 0, 0, when S and R are set to 0, the output of SR flip-flop should not change. Bakit should not change? Should not change from its previous output. So if the previous output is 1, 0, tapos nilagyan ko ng, syempre, di ba? Kung magkakaroon ako ng 1, 0 sa output, malamang yung previous input ko ay 1, 0. Tama? So pag ziniro ko yung S, dapat pag ziniro ko yung S, di ba, magiging 0, 0 na siya. So, andito na siya ulit. Dapat ang magiging output niya, no change dun sa previous output niya. So, kung 1, 0 yun dati, 1, 0 pa rin yan. Okay? Now, kung maging 0, 1 naman, so, dapat ang output niya 0, 1 din. Kung 1, 0 naman yung S and R, now the output would also be 1, 0. Now, if the S input and the R input is set to 1, now yung ating flip-flop will enter its invalid state. So, hindi ginagamit itong combination na to. As to why, ito yung sunod nating aaralin. So that invalid combination is what we call the forbidden or undefined combination. So ito po yun, yung 0, 0. Mapapansin nyo S complement R complement kasi yan. So kung lalagay natin SR, ang 1, 1 that is actually 0, 0. Ang 1, 0 that is actually 0, 1. 0, 1 is 1, 0. And ito is 1, 1. Okay, so itong ulit 0, 0. Now, anong mangyayari? Let's assume titingnan natin to kung tama nga talaga to. So, bago tayo magsimula, we have to assume a value for the output because we need that. Kasi kung maglalagay ako dito sa first scenario natin, 0, 0. So, kulang yung input nung NAND gates natin. So, usually, we assume a value. If Q is 0, then Q complement would be 1. So, ano yun? 0, 0 din yan dito, and then 1, that would be 1 din dito. NAND gate yan, kung naaalala nyo pa ang NAND gate natin. So, we have SR 00, 01, 10, 11. For our NAND, that would be 1, 1, 1, 0. Tama? Okay. So, ito yung previous, di ba? 0, 1. Okay, so napunta siya dito. Yung 0 sa baba, 1 sa taas. Now, 0, 1, 0 NAND 1, that is 1. 0 NAND 0, that is also 1. Okay. So, pag tiningnan natin dito, 0, 0, by the way, ang nakikita natin dito is, ito, naka-complement sila ha. S complement, R complement. So, when we put 0, 0 here, we are actually using this combination. So, mapapansin nyo, when we assume 0 and 1 yung present or past output nila, diba 0 NAND 1, that is 1, and 0 NAND 0, that is 1. Ang nakuha natin is yung forbidden state. Now, why is that called forbidden state? Because, sabi natin sa definition ng flip-flop, meron siyang dalawang output. Isa is the Q, and the other is the complement. So, if both of them will be 1, masisira yung definition that the other is the complement of the other output. So, this is the forbidden state. Now, what if gamitin naman natin yung to? Dito tayo sa isa. Ayan, 1, 1. Okay, so we have 1, 1. Now, let's assume that the previous state would be 0, 1 din ulit. Okay, so you will see here, ang nandito sa baba is 0, and then dito sa taas is 1. 1, 1, 1 and 1, that will give us 0. 1 and 0, that will give us 1. So, as you can see, from the previous state niya, 0, 1, to the present output, present state of the output, it is also 0, 1. Anong meaning nun? Meaning, hindi nag-change. Diba? Now, what if, balik to din naman natin. Ito naman ay 1, 0. Dito naman tayo. Yan, 1, 0. Okay? So, 1, 0. 1 and 1, anong lalabas? 0. Itong 0 na to, yan yung mag-appear dito. 0 and 0 would be 1. So, ito yun. Tama. What if 0, 1 naman? So, we have here 0, 1. So, 0 and 1, that would be 1. Tama? 1, yan yung pupunta dito sa baba. 1 and 1, that would be 0. So yung 0 and 1 pala, a 0, 1 combination will give us a 1 and 0 sa output. So pagka ito bumalik na naman ng 1, 1, ano mangyayari? Pag 1, 1 naman, 0, 0 muna. So, galing tayong 0, 1, di ba? So, what if 0, 0? So, 0 and 1, that would be 1. 0 and 1, that would be 1. So, bumalik tayo dun sa ating forbidden state. Tama? Now, paano pag 1, 1 naman siya? Itong last. 1, 1. 1 and 1, that would give us 0. And 1 and 0, that would give us 1. Tama. So actually, this 1, 1 is from 0, 0 to 1, 1, this is an indeterminate state. So yung output dito will actually vary. Hindi natin madedetermine just by analyzing the logic circuit. Okay, but from this, alam ba, 1, 0, ginawang 1, 1, alam natin, hindi siya indeterminate. Magkakaroon siya ng, it will not change. From 0, 1 to 1, 1, it will not change. Okay, now to show you, para mas makita natin yung behavior ng circuit na to, meron ako dito, ayan. So sa logic.ly, they have here ayan. So this is actually an SR flip-flop. So we can check this. What would happen if, ayan, ito nang susundin natin, 0, 0, 0, 1, 1, 0, 1, 1. Ayan. So from previous state, diba ginawa ko from previous state. So you can see here, ito yung NAND gates. Then itong switches, we have the set input and we have the reset input. If the switch is green, meaning it's logic 1, and if it is gray, meaning it is logic 0. And then at the output, we have the Q lamp and the Q complement lamp. So pagka na-green yan, meaning naka-logic 1. Pagka naka-gray, meaning yan ay logic 0. So you will see here, I will make my previous state 0, 1. Ayan to siya. SR ang tingnan nyo, wag yung S complement, R complement. So ang output niya is also 0, 1. Pag ginawa ko itong 0, 0, dapat hindi mag-change yung output ko. Ayan, 0, 0, hindi nag-change. Para ma-prove natin, what if naman galing siyang 1, 0? Yan, dapat pag nag-0, 0 ako, hindi siya mag-change. Ayun. So, tama pala itong first scenario natin. That from the previous state, pagka nag-1, 1 tayo, there is no change. Now, what if 0, 1? Kung 0, 1, yung SR natin, dapat yung output natin would also be 0, 1. Ayan, 0, 1 din siya. What if 1, 0? 1, 0 din siya. What if 1, 1? This will be the forbidden state. Bakit? Pareho sila naka-high. Diba? So that is forbidden state. Okay? So that is FR flip-flop.